Hello, and welcome to my video on technical debt. Technical debt affects every software project in some form. When used effectively, it can be a useful tool, but if used improperly, it can be extremely destructive. Like any tool, its efficacy is dependent on its user. So before we dive into this topic, we have to ask, what is technical debt? Well, technical debt is similar in concept to financial debt, hence the name. What this means explicitly is that you get a short-term benefit with the drawback of a larger long-term costs. So if technical debt ends up costing more long-term, why intentionally use it? Wouldn't it make more sense to do things right at the onset? This is a great question, and to answer it, let's borrow a concept from finance. In finance, there exists the concept of the time value of money, meaning that $1 today is worth more than $1 tomorrow. What this means is that even though a loan will cost more over time, there are still instances where it makes financial sense. Take for instance buying a rental property. You take on debt in the form of a mortgage in order to get an income stream today. This kind of debt is considered good debt because it's being used to increase revenue. That being said, there are obvious examples of when debt can be used improperly. Case in point, using a credit card to buy a large TV. So why am I talking about finance in a video about software development? Well, this example will be useful in helping to understand how technical debt affects software projects. Let's take a look at the hypothetical company. The hypothetical company is an internet marketing business. At its core is a large application that is responsible for putting ads on web pages. The hypothetical company has a major competitor, ABC Advertising Incorporated. One day, ABC Advertising unveils a new technology that allows its customers to better target individuals, and consequently, ABC is promising all of its customers higher conversion rates. Side note, a conversion is advertising lingo for when an individual clicks on an ad and ultimately follows through buying the product or service. This new development has blindsided the hypothetical company. After doing some research, the development team has determined that the time required to build out this new tech is on the order of months. However, due to the risk of losing customers, management has decided that they need to get this new feature out as fast as possible. After some more brainstorming, the development team has made a proposal that instead of building out a whole new service and all of its respective components, they can modify some existing classes and add this new functionality, thus significantly reducing development time. We can see here that this is a good trade-off. The hypothetical company can quickly roll out this new feature to their customers and remain competitive. The downside, however, is that they've taken on some technical debt. This debt has taken the form of a violation of the single responsibility principle, making their code and classes more tightly coupled. Additionally, this does not adhere to the microservices design pattern. Fortunately for the development team, the management of the hypothetical company has allocated time to separate out this functionality, ensuring that this debt does not compound over time. This is an example of intentional technical debt and when it is managed properly. Let's look at another example of technical debt. Great Solutions is a software contracting company. Businesses from across the country come to G Solutions for their software needs. Business has been good, and the company is growing. Unfortunately, though, they brought on new upper management, who is, to say the least, not the best. Owing to their experience in the private equity space, this new manager has decided that the best way to increase profits is to slash the budget. They've drastically lowered the starting pay for developers and, well, you get what you pay for. A year or so down the road and Great Solutions is running into some problems. While they've been able to save a lot of money in the short term, it's come at the cost of poorly designed applications. Due to bringing on less experienced developers to build out new apps and features, said software has been poorly designed, making it harder to maintain and more prone to bugs. To borrow a term from the developer Martin Fowler, these applications have acquired lots of cruft. Over time, this cruft has built up through poor code quality and bad design decisions. And Great Solutions is having to spend more and more time on development, leading to slower turnaround and lower quality, hurting their reputation and ultimately their company. This is an example of unintentional technical debt that is poorly managed. So what could Great Solutions have done to mitigate this problem? Well, there is nothing wrong with hiring inexperienced developers. In fact, it's encouraged. The problem lies in having inexperienced people making design decisions. To help G Solutions adhere to best practices, they could implement a code review process to help make sure only the best code gets committed. Additionally, G Solutions needs to allocate time to clean up and refactor their code base. Well, that's well and good, you might think, but what about the real world? Does technical debt happen in places besides just contrived examples? It absolutely does. Back in the olden days, software used to use 2 digits to store dates instead of 4. This was done to save memory, but had the unintended consequence of computers thinking it was 1900 on January 1st, 2000. This problem is famously known as Y2K. The consequence of this design decision is that companies all over the world had to pay their developers to spend hours and hours scrolling through code and updating dates all over. But, on the upside, it was the premise for one of the greatest films of all time. So, as we've seen, technical debt isn't necessarily bad, and it can be accrued for a variety of reasons. In the real world, dev teams are subject to a variety of pressures. These pressures include, but are not limited to, deadline limitations, budget limitations, poor development choices, poor development ability, lax best practices, and inadequate business management. If managed well, the overall impact of technical debt can be positive. However, if ignored, technical debt can overwhelm a project and lead to major problems down the road. To help mitigate against unintentional technical debt or to pay off that which is already accrued, dev teams and managers can take the following actions. Ensure high code quality. Having and adhering to good coding practices like solid or having a code review process will help mitigate against accruing unintentional technical debt. Having a strong architecture. Designing and high-level decisions should be made by skilled and qualified team members. Quality assurance. Auditing the code by creating tickets when problems are found should be done on a regular and reoccurring process. Refactor your code. As projects grow, their scope and requirements can change. Rewriting components will remove redundancies and optimize performance. So what do you think? Are there any examples in your software where you've written less than perfect code to get something done on time and/or under budget? What about unintentional technical debt? I can certainly think of many instances where I've jumped into a project with no plan, only to be left with a twisted mess of spaghetti code. What about you? Be sure to leave your experiences in the comments, and until next time, happy coding!